terms of specifically water absorption, how do the three slates compare?
Well, of all of these three, these two very often are very similar type of absorption. They will vary depending on time of year you're quarrying a particular product, but this material here, the Brazilian one, is pretty well known as being higher in absorption generally. And in actual fact, the darker the Brazilian material, the darker it becomes, often the more absorption it has, and this is just a change in the way the minerals are in some resources. And it can get to a point where there's so much absorption that it can be far more greatly affected by frost, which is reflected in the European standard that you have to often do the frost test on this material to try and prove whether it is frost susceptible or not. And unfortunately, a number of them have proven to be over the years in the UK.
And just in layman's terms, if you have a higher water absorption, what actually then happens? Why is it dangerous?
Well, it's very simple. If this had no absorption whatsoever, if a material, you can't get water into it and then you freeze and thaw it, there's no water getting into it that can then expand. This is the thing about water. Once it gets in, as it freezes, the freezing of that water causes an expansion in volume. So once you get moisture into a material and then freeze it, the expansion from inside causes it to pop open. And because we have these cleavage planes, it tends to want to go into those cleavage planes and pop them open and slowly forces all of these planes of weakness apart. And that's the key.
Is that what's called delamination?
That's called delamination. Once you get the separation of the cleavages, that's a delamination. And that is the key to most slate performance, is a low absorption, very little water getting in, therefore very little action on being able to lever this material open. And most of the problems I've seen over the years when we look at slates that have been on roofs for many, many years, often you'll see a whole series of these delaminations on a microscopic scale that are just tearing the stone apart from the inside. It's very simple, but a very easy test to do to try and work out the level of absorption. There was the old British standard test devised back in the 1940s, which required absorption to be only 0.3% maximum. It was a very tough test to achieve. The European standard test allows up to 0.6 now, and many of the UK materials do fall much lower than the 0.6. Many of the Spanish materials fall much lower than 0.6, but say the Brazilian can come in at 0.5, sometimes up to 1%, and therefore is much more of an issue. And we've got to be very careful with this product as to which grade or quality we select. And the Riverstone, this phyllite material here, as a good example, has been varying between 0.2 and 0.4 over the years, which is perfectly acceptable, very good.
I've actually noticed on the latest test report you've done for us that it achieved 0.1% actually.
Yes, it's, as I say, it goes up and down depending where you're going in the quarry. Sometimes higher in the quarry means a little bit more unloading of the stresses that have been keeping it in place, so the cleavages have opened up a little bit more, and that's sometimes as simple as that, why something will vary from day to day, and that's why you have to do regular checks, have regular tests.